Blockchain and distributed ledger technologies are fundamentally changing how information is stored, shared, and verified across networks. They represent a significant paradigm shift from traditional centralized database systems. These technologies are characterized by their inherent decentralization, transparency, and robust security features. Understanding their core structure, overarching purpose, and vast potential is crucial in today's evolving digital landscape. This exploration will provide a comprehensive overview of these transformative innovations. At its heart, a blockchain is a distributed database composed of a growing list of records, known as blocks. Each block contains a collection of validated transactions. These blocks are then cryptographically linked together in a continuous, chronological chain. This sequential linking forms the chain aspect of blockchain technology. Every new block added to the network extends this chain, building upon the previous record. The immutability of a blockchain is primarily achieved through cryptographic hashing. Each block contains a unique cryptographic hash, which is essentially a digital fingerprint of all the data within that block. This hash is generated using complex mathematical algorithms. Crucially, each new block also includes the hash of the immediately preceding block in the chain. This creates a strong cryptographic link between consecutive blocks. If any data within an older block were to be altered, its unique hash would change instantly. Because the subsequent block contains the original hash, this alteration would invalidate the entire chain from that point forward. To successfully tamper with a block, an attacker would need to recalculate the hashes for that block and every subsequent block in the chain. This process is computationally intensive and practically impossible on a large, active network. This interconnected hashing mechanism ensures that once data is recorded on the blockchain, it becomes a tamper-proof and immutable record. It makes data manipulation incredibly difficult and detectable, forming the bedrock of blockchain security. One of the primary purposes of blockchain and DLTs is to enhance trust and transparency in digital interactions. Unlike centralized systems, the ledger is distributed across numerous nodes, or computers, within a network. No single entity holds exclusive control over the entire dataset. This decentralization significantly reduces the risk of censorship or malicious data alteration by a single party. It also eliminates single points of failure, making the system more resilient to attacks or outages. The transparent nature of many public blockchains allows anyone to view transaction records, fostering accountability among participants. Blockchain technology provides significantly enhanced security compared to conventional systems. It utilizes advanced cryptographic techniques to validate and secure every transaction. Each transaction is digitally signed, ensuring its authenticity and integrity. Furthermore, DLTs employ sophisticated consensus mechanisms to secure the network and validate new blocks. Examples include proof of work, used by Bitcoin, and proof of stake, adopted by Ethereum 2.0. These mechanisms require network participants to agree on the validity of transactions before they are added to the ledger. This distributed validation and cryptographic security make it substantially harder for malicious actors to compromise the system. The collective agreement required by consensus mechanisms acts as a powerful deterrent against fraud and unauthorized changes. Blockchain technology holds immense potential to revolutionize the financial sector. It can streamline cross-border payments, making them faster and more cost-effective by bypassing traditional intermediaries. This reduces transaction fees and settlement times. DLTs can also enable the creation of new financial instruments, such as tokenized assets and decentralized finance protocols. These innovations offer greater accessibility and efficiency in capital markets. In supply chain management, blockchain can dramatically increase traceability and transparency. It allows for the immutable tracking of goods from their origin to the consumer. This includes recording every step, from manufacturing to shipping and delivery. This enhanced visibility helps in verifying product authenticity and reducing counterfeiting. It also improves accountability among all participants in the supply chain. Blockchain offers a secure and efficient way to store and share patient data in healthcare. It can improve interoperability between different healthcare providers and systems. Patients can gain greater control over their medical records. This technology ensures data privacy and integrity while facilitating secure access for authorized personnel. It can streamline administrative processes and enhance research capabilities. The application of blockchain in voting systems could significantly increase security and transparency. It provides an immutable record of every vote cast, making it extremely difficult to tamper with election results. This can reduce the risk of fraud and enhance public trust in democratic processes. Blockchain is the foundational technology for decentralized applications, or dApps. These applications run on a peer-to-peer network rather than a single server, offering greater resilience and censorship resistance. dApps are enabling the development of entirely new methods of internet interaction. They foster innovation across various sectors and empower users by giving them more control over their data and digital assets. This represents a significant shift towards a more open and user-centric internet. Despite their transformative potential, blockchain and DLTs face several key challenges. Scalability remains a significant hurdle for many networks, as processing a high volume of transactions can be slow and expensive. The energy consumption associated with certain consensus mechanisms, particularly proof of work, is also a concern. Furthermore, the regulatory landscape surrounding these technologies is still evolving and often uncertain. This lack of clear guidelines can hinder widespread adoption and innovation. Nevertheless, the transformative potential of blockchain and DLTs is undeniable, even with current hurdles. Wider adoption is expected as the technology matures and solutions to these challenges emerge. Ongoing research and development are continuously improving scalability and energy efficiency. As regulatory frameworks become clearer, these technologies are anticipated to have a profound impact on various aspects of life. They promise to reshape industries, enhance digital trust, and empower individuals globally.